This conference will now be recorded.
Let us start the session. In the previous session, the trainer would have discussed assignment operators and conditional operator, which we know from Verilog, unary operator, binary operator, unary module path operators, logical operators. Okay, and wildcard operators are missing here. Let's write down that also. It's there. Oh yeah, that is newly added in system builder. Okay. Um, we don't really use it much. Very rarely we use wildcard operator because for most of our requirements, the normal comparison operators are sufficient. Have you understood these operators? The signed shift and unsigned shift operators? And unsigned shift is basically in signed shift, the signed nature will be retained. If you shift -2, let's say, by left shift by 3 positions, ideally what would be the expectation? This is unsigned shift, right? The signed shift will become -60. Means it will shift the number. It will also retain the signed nature. Whereas if you do normal shift, it won't be -16, something else. It will not be -16. How signed shift works is MSB, it will keep it as it is. It will keep the MSB. In case of signed, it knows that the most significant bit, because -2 means what? It's a negative number. In 2's complement format, the MSB bit will be 1. MSB bit 1 indicates that it's a negative number. Correct, right? MSB bit 1 indicates what? Negative number. So when you do the signed shift, if it is 1, it will retain 1. If it is 0, it will retain 0. There is some problem with the Questa tool. We will check once, because in case of left shift, signed left shift, it doesn't work properly. For right shift, it works. When we do the right shift, it works. Let's check that also.
टमाटर मिर्ची लाए तो खोल दिए हैं, खा गए हैं। मिर्ची हम लाए एक पाव अलग, तो है बचता है? नहीं बचता है, खत्म हो गया। और टमाटर है क्या? 1 किलो कैसे पापा का? तौल के दे दो। तौल के दे दो। अभी नहीं, उसकी जब आएगी बात तब बोले वो ठीक। बुक हो गया, अभी ले गया 104 का सामान। बोला शाम को 3 थैली हमारे लिए रख दीजिएगा। पहले ही बुक कर दिए 3 थैली और। लेला 5 रुपए देता। पापा लिए 15 के 2 नहीं।
One case, what am I doing?
पालक तो दुनिया भर के पालक मिल रहा है।
This is called as what? Signed what?
पापा का अलग बात है।
Left shift. This Answer. D, comma, E. Unchained. Let's analyze what should be the values. Ideally speaking, it should be 20 minus 8 minus 160. It should have been 20 divided by 8. So let's do one thing, only let's do shift by 2 so that it will be proper. Can you write down the values, everyone? So minus 160, what is expectation here? Minus 5. In the second case, it doesn't hold the sign, it will be some other number. When you shift it by 2, what will happen? What you have to do is basically what tool does is it will convert minus 20 into this one. It would be much easy if you convert it as byte. Calculations can be very easy for us. So let's take byte because 30 int means 2 to the power of 32, right? It will be a very big number. So for us, calculations will be difficult. So this is the case, minus 20 will be how much? In months, in 20 is what? 1, 16 plus this one. Since it's a byte, how many bits you have to keep here? Totally 8 bits. Minus 1 will be what? Sorry, 1's complement. 2's complement will be what? This is 2's complement. This one. Got it, right? Now, in this case, ideally the expectation is that it should retain this sign. Because when you say sign left shift, it should retain this sign. But for some reason, it is not happening in the tool. So what happens is, it becomes like a normal shift only. So these two will go out, this will shift there. If you take the same thing, these two will go out. In the end, 2 zeros will come. What this will be treated as? Some other number, basically. Okay. Since it's a signed one, it should treat it as, let's check that part. Whereas in this case, it will be proper, because in this case, what happens is when it shifts these numbers, right, it retains this one, it retains that one. So what will happen? These 2 zeros will go out. These 2 zeros will go out. Here, 2 ones will go. See, understand that one MSB1 will continue to be 1 only. MSB1 continues to be 1 only. In this case, these 2 bits will go off. Zeros will come here. You see here, between signed left shift and unsigned left shift, there is no difference as such. And signed and unsigned left shift, there is no difference. You see the difference only in the right shift actually. Here what will happen? This one won't be retained. Here 2 zeros will come, 2 zeros will go. Now because of that, what happened? In this case, MSB is what? 0. If it is 0, it will be treated as a positive number. What is that positive number? You understand. This position is 128, 64, 32 plus 16, 48, 48 plus 8, 56, 56 plus 3, 59. It should be 59. It should be what? 128 plus 32. 128. One second. 128 plus 32. 168. This should be what? This treats it as a negative number basically. Because once you did unsigned shift, it ends up treating it as a -5. Here also it should treat it as a negative number only. Let's check once. Let's take 1's complement. 0, 1, 0, 0, 1, 1, 1, 1. What should I do? Plus 1 I should do, right? What it will come? 0, 1, 0, 1, triple, 4 zeros. What is this? 64 plus 16 minus 80. Let's see what gets printed here. So let's display all of them. So ideally, this is how I want you to practice. You don't run the tool and compare. You analyze, you expect the output. Then you run it. Now, will the tool go wrong? No, right? 99%? Tool will not go, not 99, 99.99%, tool will not go wrong. If at all there is any mistake, our understanding will be the mistake. A is what? Percentage 0D, B equal to percentage 0D, C equal to percentage 0D, B equal to percentage 0D, E equal to percentage 0D, A, B, C, D, E. So let's run it. A is minus 20. You understood why it's minus 20? I mean, that's what we have taken. B is minus 80. C is minus 5. D is minus 80. This is something which I'm doubtful. It shouldn't have been minus 80. But then, yeah. So even here, what it's doing, it's treating it as a signed nature only. It is treating it as signed number only. So it ends up taking it as minus 80. Because both these are same. This is minus 80, this will also be minus 80. You may say, what is that I should learn in this? Is that you should ask yourself, what is the type of operand? A, what is A? Is it a signed number? Is it an unsigned data type? You should ask only one question. Is it a signed data type or unsigned data type? If it is a signed data type, what shift should you use? Signed shift you should use. If it is unsigned data type, use unsigned shift. That's the basic guideline. This is all what calculation we did is only for our understanding purpose. But actual thing is, you should ask questions. So do I have in my presentation? If the operand is signed data type, then use signed shift operator. The operand is unsigned data type, then use unsigned. It will be wrong to use other way. You should not violate this. Reason is, if some number is, let's say, if I have a bit vector, I mean, we should not mix. We should not mix these. Means what? Example, I have a bit vector. Down to 0. Okay. I give bit vector equal to 8B10001. Now if I do A equal to bit vec of by 3 positions, what will be the problem? Bit vector is a unsigned data type, right? Bit vector is unsigned. It will end up taking this one as this one signed nature. So you won't get the right result. You ideally should have got, if you shift by 3 positions, this one will come here, this one will come here. Ideally, our expectation is what? 16 plus 1, 17. But it will give something else. You got it? So simple guideline. When you want to do a shift operation, whenever we want to do shift operation, you check, is the operand a signed data type or unsigned data type? It is signed, use signed shift. Unsigned, use unsigned shift. Any questions on this so far? Okay. I hope you understand this operators. You understand equality operators, right? When does X output come? Do you know that? In the logical equality operators, whenever any of the left hand side or right hand side is unknown, or Z, output is X. Case equality never gives X. It's always 1 or 0. Case equality means X is compared to X, Z is compared to Z. Then we have discussed wildcard. I think trainer has discussed. This is not important, really not very important. The reason why it's not very important is we don't use day to day, but there can be some special scenarios where this is required. What is that special scenario? You want to treat X and Z in the B as a wild cards. Means you don't want to compare them at all. But if it is there in A, you still want to treat them. You want to compare them. So that's a scenario where in B, if there is X and Z, you want to ignore those positions. In A, if it is there, you want to consider. So those cases, use wild. Next, let's now talk about the next type of operator, unary reduction operator. This is something we know from Verilog. No difference. Okay. In Verilog, we used to call it as reduction operators. Instead of unary reduction, we call it as reduction. What is the meaning of the term unary here? Single operand. If you see, this is the operation. This is the statement. Okay. What is the operand here? A is the operand. What is the operation? Unary XOR operation. We are using A is the operand. We are doing unary XOR operation. B is the output. Okay. So, and I think we have done this in Verilog, right? How it does? It does the XOR of all the bits of A. How many bits are there in A? 6 bits are there. So it will do A of 5 XOR with A of 4, XOR with A of 3, A of 2, up to A of 0. So what this operator will do? I mean, what is significance is if you get B equal, that means that indicates that A has even number of ones. If some vector has even number of ones, if you do XOR of even number of ones, what is the output? 0, right? 1 XOR 1, how much? 0. If 2 ones are there or 4 ones are there, XOR operation will give you 0. Clear? If B comes as 1 means what? A has odd number of ones. Next. If B is 0, in case of unary AND, what does it indicate? It indicates that A has at least 1 0. If it comes as 1 means what? A has all ones. If you do reduction OR, if B equal to 0 means what? A has all zeros. If B equal to 1 means A has at least 1 1. What is the practical significance of NAND, reduction NAND and reduction NOR? Can you tell me? If reduction NAND, if reduction NAND, if B comes as 0, what does it indicate? One is reduction. What does it indicate? Tell me, what does it indicate? All bits are 1. All bits are 1. It will come as 1 and output will come as 0. Okay. What does it indicate? At least 1 bit is 0. You agree with that? At least 1 bit is 0. Here, at least 1 bit is 1. Here, all bits are 0. Understood, right? We can use them. These can be useful in, these things are useful in parity checking. There could be different places where you could use this kind of things. Clear with everything? How many unary reduction operators are there? 5 are there. One is XOR, reduction XOR, reduction AND, reduction OR, reduction NAND, reduction NOR. Maybe reduction XNOR also will be possible. So all those operations are possible. Now we'll go to the next type of operator, streaming operators. Are you familiar with streaming operators before? No. Okay. Let's discuss this. This is very important operator. See, I said wildcard is not important, right? Wildcard operator is not important. That means you can ignore it. You don't need to focus a lot. Streaming operator is important. So you need to spend more time to understand what is streaming operator. First of all, let us understand what is the need for a streaming operator. What is mean by streaming? Tell me. What is streaming? Where do you come across the term streaming in real life? Live streaming means, example is what? Live streaming of match or anything for that matter. How does streaming happen? So how streaming happens? It is a broadcaster sending the information, has some data. 3 hours match, assume it's a data, 1 gigabyte of data. Assume a 3 hours match. Assume it is 1 gigabyte of data. Just taking assumption, okay. Can you see all one match in one frame? Can I see the whole cricket match in one frame, just like a photo? No, right? What do? The broadcaster sends the information. We stream that information on a frame by frame basis. See, one frame, next second, next frame. Actually, it's not second, it happens much quicker rate. Okay, that is what we call as refresh rate. In the display concepts, it is called as refresh rate. If you buy a television, you have to ask what is the refresh rate. That refresh rate will tell you how quickly the image changes in the TV. If it changes once every second, you cannot watch it like a movie. If it changes once every second, it won't be a movie actually. It has to change at least 20 seconds or 60 seconds. It is called as refresh rate. It will be generally 60 hertz. 60 frames change in 1 second. That is where you feel it like a video. That is a concept called as DisplayPort. That's a protocol called as DisplayPort, which tells how that works. Anyway, let's not go there. Let's come back to streaming operator. So we as a user stream the data, what is coming from the broadcast. How are we streaming? Frame by frame basis. Whatever frame I am seeing now at let's say at 10:30, by 11:30, that frame would have gone 1 hour back. Whatever match I'm seeing at 10:30, when I go to 11:30, what will happen to this frame I was seeing now? It would be 1 hour behind. So the frames get shifted backwards. As we see the match, the frames gets pushed backwards. At the end of the match, all the frames are there with you. By the end of the match, all the frames are there wherever you want to go, and you can see that frame. Like initially the overs have started, some break is there, that everything we can see. By end of the match, whole 1 gigabyte data is streamed and you have all the frames. It's the stream. Streaming in VLSI chips also works in similar manner. The only difference is here we are doing frame by frame basis. Here it will be done on the instead of frame, we do bit streaming or nibble streaming or byte level streaming. We do either streaming at bit level. Nibble means what? 4 bits. Byte level. Now, who will decide? How to decide? How to decide whether to do bit level streaming, nibble streaming, or byte streaming? So for that, let's take one example. We have a Ethernet port laptop. We want to send 100 megabyte file from my laptop to another laptop using LAN. This Ethernet port. Please read that statement. We want to send 100 megabyte file from my laptop to another laptop connected on LAN using Ethernet port, right? Ethernet cable. Okay. Can we send, is it possible to send entire 100 megabytes in one go? No, right? How the data will go? If my laptop has a Ethernet port, assume that it has got 8 wires. Just for convenience, assume it has got 8 wires. How that will go? 8 bits at a time. There are 8 wires. How much data it can carry at once? 8 bits. Let me again repeat. Imagine a laptop. You have a laptop. In that laptop, there is a Ethernet port. If you open the Ethernet port and see, you will see the wires, right? Roughly, you see 8 wires. You can count. It may have 8 wires actually, different colors. Why those wires are there? To carry the information, right? From my laptop to other laptop. If all 8 wires carry the data, in one go, one cycle, how much data will go? 8 bits of data. So in this case, so the Ethernet port has 8 pins. Assume. Okay. It can carry 8 bits in one cycle. It can carry 8 bits in one cycle. So to send 100 megabytes of data, we need to arrange the data in queue of 8 bits each. Like simple example is we want to send 100 people from this room. 8 people can go at once. let's say 120 people, so that even number. Okay. So we'll make them stand as what? If this is my room, this is the door where 8 people can go. We'll make these people stand in each having 8 people. 8. How many such rows? 15. So in one cycle, 8 people will go. In next cycle, 8 people will go. The same concept is called as streaming operator in this system. You got it right? What is streaming operator? You wanted to, basically, it's, then you may say, is it about sending the data? No. What streaming operator does is, changes the data queue of required format. Means if your door was only capable of holding 2 people, it will arrange 2 people. If the door can accommodate 4 people to go at once, same 120 people will be arranged as 430 rows, 4 next set of 4, next set of 4. That is what streaming operator will do. Responsibility of streaming operator is not to send. Streaming is only to arrange. Okay. Then going out is something we have to. You got the idea? What is streaming operator? Now let's understand the streaming operator. Output of streaming operator is always a queue. Let's say I have one packet, Ethernet packet, assume Ethernet packet. It has got something like header, length, payload, and CRC. How many fields are there in the Ethernet packet? 4 fields are there. Header, length, payload, and CRC. We are streaming at a byte level. What are we streaming at? Byte level. So data, finally, when you stream it, this data queue will have 8 bits at a time. In this case, this direction is important. The direction will tell what are you streaming first. So if this is the direction, the lower 8 bits will be streamed first. If this is my queue, because of this arrow direction, what will come first? They will. This is the front of the queue. This is the back of the queue. Next moment, next time, what will be streamed? Next 8 bits of the CRC. Next 8 bits of the CRC. Because this arrow direction, because of that arrow. By the time what will happen? This will go back. This will come to this. I told you the cricket match example. When you're watching, what you're watching now, after 10 minutes, that would be 10 minutes back. Because we are getting a new frame. The old frames gets pushed back. Next moment, what will happen? Next 8 bits will be, they will come here. This will go here. This will come. By the end of this streaming, actually speaking, this whole thing happens in 0 time. Because there is no clock involved. This whole thing finishes in 0 time. Then why am I taking this? I'm explaining them because you are feeling that there is a time involved. There is no time involved here. All happens in 0 time. By the end of this operator, can you tell me what will be there in the front of the queue? Header most significant 8 bits will be there. Header most significant means uppermost bits will be present. What will be there in the end of the queue? CRC lowest 8 bits. Lowest 8 bits. Lowest significant 8 bits. Understood, everyone? Now, if I do the same thing, if I change this operator to this direction. So what will be there at the front of the queue? CRC what? CRC LSB will be there. Because when you stream it, this will be the last thing to get streamed. That will come to the front of the queue. What will be there in the back of the queue? Header, most significant. Again, let's understand. Because you are shifting in this direction, because you are shifting in the left direction, what will be streamed out first? This will be streamed out first. So it will come here first. Then you may say it should be the first one, right? That's not how it is, right? If you watch the cricket match, you don't watch reverse. You watch the one direction. So whatever frame you're watching, it shifts back. So when a new frame comes, this goes. When again the next byte comes, this comes here, this comes here, that keeps happening. By the time the whole streaming happens, header is in the back, CRC is in the two CRC lowest bits. Now, again, let me tell you, this entire operation takes only 0 time. You may be thinking, will it take time? Will it take some clock cycles? Will it take, let's say, if there are 50 bytes totally, will it take 50 clock cycles? No. This whole thing will get over in 0 time only. Let's say if I tell you how much time does 35 into 46 into 76 take in a laptop? 0 time only, because it's a combinational operation where you are just multiplying. There is no delay involved in this. So streaming operator also doesn't have any delay involved in it. So because you are streaming at what level? Byte level. So data queue will be queue of bytes. If I had taken bit, queue of bits, how much information will be streamed bit by bit? Can you tell me what is this operation? This operation alone? Concatenation. What are you doing? You're concatenating people. It's like there are different types of people here. All of them you're putting into one queue. Right? You understood, right? People from different places, you're just putting them into queue. Then you're sending them. If the door is capable of only one person, how you will send one person at a time? That will become bit streaming. If the door is capable of 8 people, if it can hold 8 people to go at a time, you do byte streaming. Now you have to decide whether to stream from the front of the queue or back of the queue. Accordingly, you decide this. In this case, what will be at the 0th position at the front of the queue? In front of the queue. CRC 7 down to 0 will be there. What will be in the end of the queue? Header 31 down to 24. Assuming header is 32 bits. Now, streaming operator can be used for other bits also. Other bits also, bit also. Hence we can use on nibble, whatever you want to use it, we can use it. For example, if you want to use it for nibble means how many bits? 4 bits. Is there any nibble data type in System Verilog? Like we have byte data type, bit. Is there nibble data type? That is where System Verilog provides a concept called as user-defined data types. Since nibble data type is not there, you can define your own nibble data type. Let me again repeat. If you want to declare a 8-bit signed variable, I want to declare a 8-bit signed variable. Do I have does System Verilog provide me such data type? Yes. Byte is a 8-bit signed data type. I want a 32-bit signed data type. What can I use? Int. Either int or integer. But do I have a 4-bit data type? No. That is where I can declare my own data type. You just write base. Make it data type. Now, nibble underscore t is a data type. Like you declare byte t, now I can declare nibble t n. It's nibble underscore t here is a data type, which represents a 4-bit vector. Now I can use that, you see. Once I've declared the data type, I can use the data type to declare a queue of nibbles. Same data type, I could use it in streaming also. You may say, why don't we use like this only directly? How about using this only? Anyway, you're doing 4 bits. Can we use bit 3 down to 0? The tool doesn't support it. Tool doesn't support you writing bit 3 down to 0. Tool only support this is correct. One is wrong, second one is clear to you? Let's do this exercise. What am I doing here? ABC. First, what am I doing with ABC in this line? Concatenation. When you do concatenation of ABC, what do you get? When you do any concatenation operation, what is output? Vector. So for a streaming operation, vector is always an input. For streaming operator, vector is an input. Vector is the input for streaming operator. Streaming, you're concatenating. So when you concatenate ABC, you have got a big vector. Each vector is 32, 32, 32. So what is the concatenation size totally? 96 bits. Now tell me, after this, what is in the front of the queue? What byte? You are doing byte level streaming, right? Which byte will be at the front of the queue? You have the numbers 1, 2, 3, 4, 5, 6, 7, 8. Tell me. First, you analyze yourself, sit calmly, just see what direction we are doing shifting. Okay. Then first you ask yourself, what will go first into the queue? Okay. Then what will go in last into the queue? Because last one is the front of the queue, right? Last one is the front of the queue. Tell me. Tell me. Tell me. What is the answer? Tell me. How much? Is 8 1 byte? Does 8 means 1 byte? Byte requires how many characters? Hexa characters. 2 hexa characters. It will be 88. What will be there in the end of the queue? End of the queue. Back of the queue. How much? 1, 2 will be there in the back. So if I print it, if I run this code, one, 2 is coming. 88. 88 in the front of the queue, 1, 2 in the back of the queue. You got it? Whereas if I do the reverse operation, what does it mean by reverse operation? Change the direction. Reverse will happen. Clear, right? How it's working? See, when you concatenate, how it will happen? You imagine what will happen. This followed by this, followed by this. 88 will be in the end, 12 will be in the MSB. Accordingly, you are. Because you are shifting MSB first, MSB will go to the back of the queue. Do you understand that logic? LSB will come to the front of the queue. Any questions so far? So this is about streaming operators. Streaming operators are useful or compulsorily used in every peripheral bus protocol based designs. Peripheral bus protocol means what? Everything you see at the outside of the laptop is a peripheral protocol. HDMI. In my laptop also streaming is happening, because when I'm playing this my data onto the projector, do you see everything happening in 1 second? My 3 hours lecture, does it happen in 1 second? What is happening basically? My data is getting streamed to the projector. So everywhere in the peripheral protocol, streaming is required. So even for a verification engineer, he should know how streaming works, because in the test benches also we need to implement streaming. For example, PCI Express, Ethernet, USB, SATA, any protocol you take, HDMI, all these protocols will compulsorily require streaming. The fundamental concept is this one. When you go to PCI Express, streaming doesn't get complicated. The fundamental concept remains same. Now, only thing you have to ask is, which one should go first? Most significant bit should go first, or least significant bit should go first. Accordingly, you have to choose the direction. Let us now talk about shift operators. I think we have already discussed shift operators, right? Shift operators, I think we have done in Verilog, right? How we can do multiplication using shift operator. In 65 into 97, I've told you, you have to shift it by 6 positions, 1 position, and add it. Same concept. I'm going fast here because we have already done it in Verilog. Next, let's go to the next important operator called as set membership operator. What is set membership operator is? First, let's understand what is a set in mathematics. What is a set? Group of elements. Group of elements is called a set. Simple, right? Here also same. Set means they are referring to the mathematics set only. Membership means what? We are checking, we are looking for someone. Let's say there are group of 10 people. Okay. Group of 10 kids. I want to go and check whether my son is there in that group of 10. Okay. Instead of checking each kid, all I can say is check this person is in the group. If it is there, it will tell us it's there. So in simple terms, what is this represent now here? Here it represents a set. You know, right? In mathematics, how do you write a set? Flower bracket. Here flower brackets indicates the set, not the concatenation. Understand here, the flower brackets in this operator indicates a set, not a concatenation. See, flower bracket itself has different meaning in different places. In one case, it was used for replication purpose. In one case, it's used for concatenation purpose. In one case, it's used as a set. So you should not get confused. You should have that clarity. You should have clarity that when a flower bracket comes, I have to understand where, in what context is it used. If it is used in the context of inside, it becomes a set. It becomes set. So what are you checking? Very simple. If A inside, B, C set. Means what? You are checking if A is equal to either B or C. What are you checking? Checking if A matches with B or C. Here, what are you checking in this case? Sorry. Again, if A, checking if A matches with 1 or 2 or any of elements in array. Three elements, three things are there totally. Number one, number two, and array. Array itself can have many elements, right? It checks with all of them. Very important, very useful, right? You don't need to check each and everything individually. You don't need to write A equal to B or A equal to C. You don't need to write that. In this case, you don't need to write A equal to B or A equal to C. Here also you don't need to write A equal to 1. So what if without set membership operator, how will you do this? Write if A equal to 1 or A equal to 2. Array is also even more complex. What you have to do? Then again you have to go through one more loop for each of array of I. Then you have to write again a more complex code. If array of I is equal to A. A lot of code will be involved. That whole thing can be done in one line. Now, did you understood what is set membership operator? Tell me, doesn't it make it easy to do the coding? Right? What takes more lines gets reduced. That is what System Verilog does most of the times. It reduces the complexity of the coding. Inside expression. I think we have gone through it. You can even create a set of multiple arrays. Here, how many arrays are part of set? 2 arrays. Whatever you want to keep it, you can keep. Even you can keep a queue, you can keep a dynamic array. Whatever you want to keep it, you do it. The set membership operator is smart enough to understand everything. It knows whether the element is an integer, whether the element is a queue, whether it's a static array. Accordingly, to you can even check a string. This is a string. You can check with a string array, individual string, everything. This is about set membership operator. So if it is there, if condition will be true. If it is not there, if condition will be false. You understood when I say set membership operator will return either 1 or 0. When will it return 1? If the element is there in the set. When will it return 0? If it is not there. Next, we'll go to the next type of operator, that is concatenation operator. You know that, right? From Verilog. How do you achieve concatenation using flower bracket? System Verilog allows concatenation of bit streams, integers, arrays. Only one thing is, only one element of array can be used, not the whole array. You cannot concatenate entire array. And you can even concatenate strings. Okay, when you're doing concatenation, where you should be careful. I mean, what precautions should you take? That concatenation should always have variable with bounded sizes. Any concatenation with unbounded size variables, tool takes that variable default size. Understood this? If I take this example, this case, I'm concatenating these numbers. A equal to 8 tick H10. Let's say if this is what is my question. Can you tell me what will be the value of A in this case? End of this operation, what will be the value of A? A I have declared as 32-bit logic variable. B I have declared as 6-bit variable. I'm concatenating A equal to 8 tick H10, 16 tick H12, and 9. What will be the value of A here? How much? 9021. You're again confusing. You're doing streaming and all that. See, assignment is very simple. Assignment will happen in normal direction only. Assignment won't happen like this will go here, this will go to MSB. It won't happen like that. When you assign, MSB will go to MSB, LSB will go to LSB. Do not mix vector assignment with streaming operator. Am I using streaming operator here? No. Now tell me what will be the value of A. Is it A equal to 10129? Is that correct? Is that correct? It is wrong. A will be 9 actually. A will be 9. This is the correct. Why is it so? Let's understand. This is a bounded size. Means what? When you say bounded size, means it has a boundaries. Size of that variable is 8. What is size of this? 16. What is size of this one? It is unbounded. Means you haven't given any boundary. If you don't give any boundary, it takes a default boundary. If you don't give any boundary, it takes default boundary. For a 9, what is the default boundary size? 32 bits. Because 9 is a integer. For integer, the size is by default 32 bits. So you are concatenating 32 bits plus 16 bits plus 8 bits. Totally, how many bits will you get? 48 plus 7, 56. You will get 56 bits. Now when you do A equal to this operation, right hand side you have 56 bits. Left hand side, what is size of A? 32 bits. So what is this scenario? Right hand side vector is bigger than left hand side. So how the assignment will happen? Only LSB bits will be taken. What is the LSB bits of A of this vector? 9. Lower 32 bits will be taken. Which is lower 32 bits? 9. Understood why A will be 9 here? Which bits will be ignored in this case? This entire data will be ignored. It won't be copied at all. It will not be copied at all. Only 9 will be copied. Because you have used a 9 which is unbound. How can I solve this problem? I need to give a size. If at all I have something, I have to declare 8 tick H9. Then it becomes bounded. Then it becomes bounded. Now tell me what will be the value in this case. If I use this, what will be the value of A? Please be little smart. Think. This is 8. This is 16. 16 means what? What should happen? Like that you think. Tell me now the answer. Please write it in your notes. You write it. See, 12 means 16 means how many hexa characters are required. Like that. That is the hint. Hint I am giving you is, if it is 16 means how many hexadecimal characters are required. Like that you think. You will get the answer. I want you to think little smart, little bit. I mean, what will be taken for this one? What will be taken for this one? What will be taken for this one? So let us do this. In this case, the output will be 32 tick. First of all, you have to write size 32 tick H 10 0012 09. Why? Because 9 only represents 4 bits. One hexa character only represents 4 bits. To get 8 bits, how many hexa characters are required? 2. But it doesn't have the second one. So how do you extend it? By adding zeros, right? In the MSB, you have to add zeros. It becomes 09. Same thing, how many zeros you have to keep for this? 2. Why? 16. 1, 2 will give me 8 totally. I have to add 8 more bits, which is zeros. For this, do I need to add any zeros? No, because already 10 means 8 bits. So this is the answer. You understood? We can run the same question. The simulation. Is this you can display A here. If you have understood the concept, that is sufficient. That is what is that is the important thing. You got the idea? You need to know the sizes. You should see what is the size accordingly. If its size is not given, you should take it as 32 bits if it is integer. So to run this, in one case, all zeros in the end, 9. Second case, 1 0 0 0 0 1 2 0 9. Got it right? So that is about. See, 9 is unbounded, treated as a 32-bit vector. Hence, 32 size is used. So answer will be this much. Actually, I can even write this. Upper 28 bits are treated as zeros. Hence, while using a number, it is good to give size of the variable. Let me just. I have asked the same question. Okay. Whereas if you have given, okay, in this case, what will be the output? Tell me. Since you haven't given any size, it will take whatever is there here. 5 bits are there, it will take 5 characters. It will treat it as a 20-bit vector. Since you haven't specified any size here, it will take it as 20 characters. 8 characters from here, 20 characters from here, 28. So 0 will be taken from here. You understood? So when you don't give any size and write tick H, it will automatically treat only that much size only. You can even use B here. During concatenation, avoid using unbounded variables. This is about concatenation. It's not operators, operator. Conditional operator. You know conditional operator from Verilog, right? A condition, question mark, B colon, E. I think we have done display also, right? One display example, same concept. So which one is preferred, conditional operator or if else? Most of the time we prefer conditional operator. Reason is, conditional operator can be used in both assign and procedural block. Assign statement and procedural block. It gives a concise description. Conditional operator gives a concise description. If else can only be used in procedures, can't be used in assign statements. Assign A, this is not possible. This is not possible. Assign A equal to if B equal to 0, C else D. It is not possible in assign. Because in an assign, we cannot use if else statement. Whereas this is possible. Clear? So which one will you prefer? Conditional operator. You remember that example we did in first or second session of the day, red, yellow, so that you have to practice again. See, don't think that tomorrow when you go to a job, you will have to print red, yellow, green only. What I have given is an example. There could be different examples also. I will show you one possible example. Okay. There is a AXI transaction. I'll explain here. Maybe in 1 or 2 months later, you will be learning AXI protocol. There are 3 types of bursts in AXI. You see, take a look. Burst is a 2-bit variable. In AXI protocol, there is a variable called as burst. It is a 2-bit variable. 1 down to 0 means what? 2-bit variable. If it is 0, 0 means what? Fixed. 0, 1 means incrementing. 1, 0 means wrap. 1, 1 means reserve. Now, I'll take one example. Initial, begin, end, color display. Let's say I generate random burst. Generated randomly the burst value. I will say burst equal to percentage B. Repeat. It's a 5 times begin end. Clear? Okay. If I run it now, it is showing me 0, 0, 0, 1, 0, 1, 1, 1, 0, 1. Do you understand what is 0, 0? Unless you remember in your mind, 0, 0 means fixed, 0, 1 means incrementing, 1, 1 means reserved. It's difficult. After a few weeks, you won't remember because it's very easy to get confused. Even unless I see, I have taught this topic 20 times. 21st time also, if you ask me what is what, I'll be confused. Okay. So what is the easy way to handle this if you want to print it? Here itself include. First equal to percentage. Equal to 2 tick B, 0, 0, question mark, colon. Again, burst equal to 2 tick B, 0, 1, question mark. What is it? Incrementing, colon. Burst equal to 2 tick B, 1, 0, ramp. Other one I know. In the other case, it will always be reserved. Now, last time I said that you can do it in a better manner where you print like this. Look better. Now, if I run it, fixed burst, incrementing burst, reserved burst, incrementing burst, like that. So again, I am telling this, this is not the only example. Anywhere you see that kind of mapping, you have a name and a value. Everywhere you can use this kind of concept. Okay. Now, how do you get this expertise? By practicing this 4 or 5 times. Just by looking at my lecture or sitting in this classroom, you are not going to learn. You have to go home and do the same thing. You have to try the same thing without referring to anything. You have to sit and start doing in your laptop and see why you are not getting out. Then you will start understanding that, oh, I missed question mark. I missed colon. I missed percentages. That kind of questioning should come. Then you learn the subject. Coding is something you learn by practicing many times. Okay. I think we have done the same example in Verilog. This question. The same thing we have done in Verilog. I'm not going to explain. Please read through this once. Okay. Next. Little more deep into conditional operator. Conditional operator implements a multiplexer behavior. What does it implement? It implements a multiplexer behavior. If selection is unknown, for example, in the multiplexer, if selection is X, what will be the value? X. Let's say this is 0, this is 1. Let's say this is 17, this is 13. What will go here if it is X? X will go. X will go. Let's read through it once better. If the condition is unknown or high Z, the output is the default value of the variable data type. Please read this once. If the condition is unknown or high Z, then the output is default value of the variable data type. Let's understand the statement. See, these kind of statements are little complex statements, which you should get used to understanding that statement. You should read it multiple times and understand. Then output is means what? What will be the value of output? What is output? Default value of the variable data type. Let's say in this case, D, A conditional operator, B colon C. If A is either X or Z, A means what? The condition. Then D will check if the corresponding bits in both B and C are same, then it will take that value, else it takes X. What is the difference? This is different behavior from if else, where if else will take else condition value. Let's understand through one example. What is A here? X. A is an unknown value. A is an unknown value. So what it will do is B is 20, C is 30. 20 means what in binary? 16 plus 4, right? 30 is what? Right? In this case, A will be, first it compares the first two characters. First lowest bits are what? In both A and B and C? 0. So for condition operator, there is no conflict. For the lowest bit, C is also giving 0. B is also giving 0. What will happen? D will take 0. So the lower bit of D will be what? D. Lower bit of D will be 0. It does operation by bit basis. Next, it goes to the first bit. What is the first bit value in C? 1. What is the first value in 0? In B? 0. Are they matching? No. There is a conflict, right? So in one case, it could take 0. In one case, it could take 1. So the value can be either 0 or 1. So our output will become what? X. Because you don't know for sure whether it is 0 or 1, it will come as X. Let's go to the bit number 2. Tell me. 1 will come. Bit number 3, X. Bit number 4, 1. And that's all. It does bit basis. It does it by bit basis. See, I will tell you other scenario. Same thing, same question. If D is 1, tell me what is the output? D is 1, sorry, A is 1. If the condition is 1, what will be the output? It is 20, simple. If it is A is 1, there is no conflict. B will be taken. If A is 0, C will be taken. The problem is when A is unknown. If A is unknown, then it will do bit by bit level mapping. Understood? So we can run the same example. Simple. Take this. Dollar display D. Is a problem. First, you should write. It should be the expression should be later. Is it? D is equal to percentage B D. You can even try to print it as a decimal number. We'll declare it. ABCD. You understand? 1x, 1x0. And as a integer, it comes as capital X. Capital X indicates what? Some of the bit positions are X. Not all. Some of the positions are X. Then it will come as capital X. If all are X, then what it will come? Small x. What if you can try the same question? What if it is 1? Tell me what will come? 20 will come. No confusion, right? Because 1 means you are compulsorily taking the true condition. So it will come as 20. If A is 1, then B will be. When A is 1 or 0, there is no conflict. When conditional expression becomes unknown, X, then that bit level thing you have to do. This is different behavior from if else. In the if else condition goes. If condition is not true, it will always go to else condition. Now, you know what is equality operators, right? You know, unary reduction operators. These are not relevant for this situation. Definition we are done. Conditional operator we just now done. Increment and increment, these are very straightforward. Only thing we need to understand is what is meant by pre-increment, what is meant by post-increment. So there are two things. One is plus and minus. If I write this one, A, B, C are integers. In this case, what will be the value of B? Tell me. You're doing pre-increment. See, it's like first increment, then assign it to B. So what will be the value of B? What will be the value of B? 16. Because first you are incrementing to 16, then you are assigning. That's why it's called as pre-increment operator. In this case, tell me what is the value of C? First assign A to C, then increment A. So called as post-increment operator. So I'm not going to run this example because it's straightforward. These can be used in for loop. Instead of writing A equal to A plus 1, you can write A plus plus. This code, if you run, this doesn't work. You're going through a for loop and printing all the elements of an associative array. You're going through the for loop and you're going through a for loop and printing all the elements of associative array. Here, you're instead of doing I plus plus, here you are doing. Let's say here if I write I equal to I plus plus, this will be a problem. Increment value never takes effective. So hence it will not work. If at all you want to do I equal to I plus 1 as a statement, you should always do I equal to plus plus I, not I equal to I plus plus. Increment happens first in this case, then assignment happens. So this will work. The point we are talking is, one is best is you do I plus plus here. No confusion. If at all you decide to do inside, why you decide to do inside? Only if array has that element, doesn't have element, then only increment. It should be done in this manner. Or if you don't want to go roundabout, you do just I equal to I plus. This will also work. You may say, why are you explaining complex things? In interviews, they try to complicate things. When you go to the written exams, they'll give not straightforward way, they'll give roundabout way like this. Same I equal to I plus 1, they will write like here and they will tell you what will be the answer. So what are they questioning here? They're questioning the concepts, like whether increment will happen first or whether assignment will happen, what will be the output. They will ask that kind of tricky questions. That is about increment, decrement operators. You know arithmetic operators, right? Do you know integer division and real division? Do you understand what is integer division and real division? We have already discussed it in Verilog. Tell me, what is this division? Is it integer division or real division? Real, right? 100.0. What is this division? Integer, because 100 is integer, 2 is integer. The practical use case is what for division? Clock generation. Let's say you want to generate a clock of 30 megahertz. You have to divide it with 1.0 by 30. You should do a real division. If you do 1 by 30, that will be a problem. 1 by 30 output will be what? 0. Whereas 1.0 by 30 will be 0.0333. So it accordingly, you have to use real numbers. When you know that output is real, should do. Do you understand the point? See, you may think both of them are same. 1 by 30, 1.0 by 30. What is the difference? Or just for quite confusion, you should write 30.0. You may ask, what is the difference? Difference is, in one case you are using 1 by 30, in one case you are using 1 by 30.0. First one becomes integer division. Because it is integer division, output will come as an integer, nearest integer. This will come as real number. Or otherwise declare frequency as a real number and do 1 by frequency, it will become real division. Either numerator or denominator should be a real number. The last topic, with that we'll conclude. Replication operator. We have already discussed replication operator, right, in Verilog? Okay. Let's discuss this quickly. This is how you write a replication operator. I think there is a mistake here. We should have written. This is fine. So if, sorry, you mean here outside? Huh? Before, where? Here. No, we can run this one. Let's see. Now when I merge it like this, when I do the replication and concatenation, let's display it. Let's write reg 20 down to 0 cat, even 30 down to 0 cat. Let's display it. We know that here replication and concatenation happens. Only thing is we're understanding where to use the apostrophe. Right? There is a problem. Let's try without. Let's see first of all what happens. Is working without that operator. Okay. So as I said, few times we have to do the experiments, because anyway tool is there to correct our mistakes right here. So even if I tried here, tool will correct me. So there is nothing. Replication operator helps assign vectors with required number of ones and zeros based on the vector size. I would return reg width -1 down to 0 valid. If I want to make all bits of valid as 1, if width is 6, then valid will be what? 6 ones. If width is 4, valid will be 4 ones. In some other project, width is changed to 10. So how do I change it? So I cannot write like this. Here you can use the replication operator. How do you use replication operator? Here is make all bits of valid to 1. You write like this. Valid equal to tick width in the flower bracket 1 tick b1. Here what is wrong with this one? 1 is unknown size. 1 is unbounded size. Unbounded. That will be a problem. How to make sure variable number of ones are assigned and a parameter value? Right. Valid equal to tick size 1 tick b1. If you want 10 to be replicated, you write 2 tick b10. 2 tick b10 gets replicated. You understood the point, right? In summary, if I want 1 tick b1 to be replicated with the number of times, I have to use this kind of. This one is wrong. If you replicate 1, 32 bits will get replicated, not 1 bit, because it is unbounded. This is about replication operator. Like this, I can use many places. For example, I want to check ready equal to size number of ones. So I can write weight ready equal to replication size 1 tick b1. Okay. Next. So, Replication operators, tick define width 20, valid tick width 1 tick b1 means valid gets replicated, 1 bit gets replicated 20 times. Here width gets 1 gets replicated 5 times. So replication operator can be useful in this kind of requirements. So if I want, okay, can you write this pattern using replication operator? Just see the pattern, what is happening. What is happening? Tell me. 1 0 1 0 1 is replicated. How many times? 1 0 1 means 3 bits. What is size of this vector? 30. So how many times replication? 10 times. Can you write that? So how to do that? Not right. Data equal to flower bracket. How many times? 10 times. In the flower bracket, 3 tick b 1 0. Got it, right? So more important is to know in what context this can be useful. Let's say you know that some pattern needs to repeat in the same vector. Same vector, you should go for replication operator. Next. I have a vector valid. I want to assign all the positions of vector as x. I can just write tick bx, tick bx. So all bits of D are considered as if I want all bits to get z, just write tick bz. You don't need to give the size. Z always gets extended as Z in the MSB. X always gets extended. If I want all zeros, right, just 0 or tick B0, both are same. Only thing is it doesn't work for tick B1. If I want to make all bits as ones, I cannot write tick B1. We must use replication operator or manually write entire pattern. Got it what I meant by that? If let's say if valid is, let's say if valid is, for example, 3 down to 0 valid. after this operation, valid will be 4 tick B, Z, 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 Z. Here valid will be 4 tick B, X, X. For 0, very simple, no need to do anything. Valid is 0 means what? Either you write tick B 0 or 0. Valid will be what? Anyway, 0, right? But for this one, it doesn't work. Means what? Valid will be what? For tick B, 0, 0, 0, 1. 1 will not get replicated. Okay. We must use replication operator or write manual entire pattern manually. In which cases 1 gets extended? Tell me. Here 0 is getting extended. In which cases 1 get extended? Signed operator. The 1 extension happens. Extension happens for signed numbers. When the sign is negative, the number is negative. That is also important thing. For signed variable, signed extension happens. This is about this one. Next, operator overloading. This is not at all required. I'll just give a very quick, brief outline and stop because you will never use this concept. What is operator overloading is? Till now we have understood plus can do addition of integers, real numbers. Plus can do what? In addition of integer to integer, integer to real. What if you want to do plus for something else? Floating point, I mean some structures and complex things. That is where you can do something called as operator overloading. By using operator overloading, you change the behavior of a plus completely. Your own definition you introduce. Through that concept is called as operator overloading. It is really meant for verification engineers or VLSI for that matter. Because we don't have to do overloading and all that. We are here to verify the design. We are not here to check whether how plus works, how minus works. All that. So you don't really need it. It will only confuse you. So we are skipping this topic. Then you know the concept of operator precedence, right? Multiplication and division has higher precedence over plus and minus. User can change the precedence by using parenthesis. If I do this, what will happen first? B into C will happen, then plus D will happen. B into C happens first, followed by addition. If I want to change that order, you keep C, D, C plus D in the brackets. Like above, we can change the precedence of any other operator also. So this is about operators. So please go through these topics. Okay. In the next session, we'll discuss whatever doubts you have. Okay. Tomorrow will be like a revision session. It's like trainer will be coming and asking around, I will come around 30-40 questions. You will have to, he will be picking each one of you and asking one question. Each one may have to answer 2-3 questions in the round. Okay. It's for both online and offline students. Whatever topics done till today will be focused in it. So you have to revise everything till operators. Okay. Only when you are good with this till these topics, then we'll move to the next topic, object-oriented programming. So this completes one part of the training. Okay. So we'll still have another 2 parts. Next major part is object-oriented programming. Next will be the after object-oriented. Okay. So let's end this session.
This conference is no longer being recorded.